Good evening, everyone. I request Deepashri ma'am to conduct the session.
Okay, good evening, good evening. So, is my voice audible?
Yes, ma'am, it's audible, ma'am.
Okay, so let's start. So, today we will be starting with the enthalpy. Okay, so last class we did a lot of numericals. I hope no one has any doubt, right? Okay, so starting with enthalpy, what is enthalpy? Enthalpy is also a type of heat. Okay, enthalpy is also a type of heat, and most of the chemical reactions in chemistry, I'm talking about chemistry. In chemistry, most of the chemical reaction occurs at constant pressure, and this heat at constant pressure heat at this constant pressure is referred to as the enthalpy. Okay, so uh, delta H, delta H is a state function. We already know, we have already learned this. And H is equal to U plus PV. This is the general equation. Delta H, delta U, and delta PV. Now I will be telling something from this. So accordingly, you will understand. Now, heat at constant pressure. Okay, this is heat at constant pressure. So this will be QP. Q, and this is heat at constant pressure, which we refer to as the enthalpy. And what was del U? Delta U is heat at constant volume. Okay, remember this because while solving the sums, we need this. Okay, try to remember this. So up to this, everything is clear. Try to interact and say, if you are not saying, I am just moving to next slide. Okay, now suppose if pressure, there are three conditions. Okay, see, if pressure is constant, then V is variable. Okay, if this is the case, we write the equation as delta H is equals to delta U plus P delta V. Okay, if our volume is constant, but pressure is variable. Okay, then we write as delta H is equals to delta U plus V del P. Okay, we write the equation like this. And if both V and pressure is constant, sorry, if both V and pressure is variable, both are variable. Then we get the equation as delta H is equals to delta U plus delta of PV. Is this part clear? Up to this, is this part clear to everyone? Say.
Yes, ma'am.
Yes, ma'am.
Okay, good. Now, what is the relation? Now we will be writing about the relation between delta H and delta U. We will be writing this relation. So let's just suppose both are variable. Delta H is equals to delta U plus delta of PV. Okay. So delta H is equal to delta U plus P del V. How can we write this equation? We can write this equation when our pressure is variable and volume is variable and pressure is constant. Okay, so we can write this when pressure is constant and V is variable. Just now I taught you. Okay, so this equation delta H is equal to delta U plus delta NG RT. Why? Because remember, we always considered the ideal gas in our system. PV is equal to nRT, right? So just for this, we write it as, instead of N, we write it as Ng. So this is the important formula you have to remember. Up to this clear? Is this part clear? Is this part
Ma'am,
clear?
what is NG, ma'am?
Yeah, say.
What is NG, ma'am? NG.
N is same as N. N is the number of moles. Number of moles of reactant, of product minus number of moles of reactant. Okay. In an equation, what is the number of moles? Just the coefficient, right? If we write as PCl5, PCl3 plus Cl2, here 1, 1. These are the moles. So 2 minus of here 1. So this is 1. This 1 is N. Okay, is this part clear? N is same as Ng.
Yes, ma'am.
Okay, so I'm rubbing this out. You don't need it here. Just to make you understand, I said you this. Okay, up to this now. What are the units we will be considering for doing sums here? Units. We will be taking delta H in kilojoule. Okay, delta U in the kilojoules. Delta Ng. This is just nothing. This is something I will say that this is the moles only. These are the moles. Okay. Then R. Value of R here you will be taking it as 25/3 joule per mole Kelvin. This is something like 8 point, but for the sake of calculation, I am writing it like this. And temperature, you will be taking it as Kelvin. So, delta NGRT, you will be getting, if you consider these units, then you will get the delta NGRT in joule. And what you have taken H in kilojoule. So joule divided by 1000 will be kilojoule. Okay. So when I will be doing the sums, then you can understand it more better. So if we consider it like this, then we will be getting NGRT, unit of NGRT in joule. What was our equation? H is equals to U plus PV, right? We are taking this in kilojoule, this in kilojoule, and this has come out in joules. So in order to convert this into kilojoule, we are dividing it by 1000. Okay. Is this part clear? Is this part clear?
Yes, ma'am.
ma'am.
Okay, so say then. Okay, one more thing I have to teach you now. Case 1. Case 1 is if delta Ng is greater than 0, then our delta H will be greater than delta U. If this is case 2, if our delta Ng is less than 0, then our delta H will be less than delta U. If our delta Ng is equal to 0, then our delta H will be equivalent to delta U. Is this part clear? These are the 3 things. Now we will start solving the question. Take a screenshot or whatever you need this to solve the question. You need this part, this red ink part to solve the question. Up to this, is this clear? Can I move to the next sum? We will be doing
Yes, ma'am.
sums now. I know I am a bit hurry. You can always check the recording and can ask me for doubts. The question is delta H less than delta U for which of the following reactions? Option A. Option A is PCl5 is PCl3 in gas plus Cl2 in gas. I will be teaching you, then you can solve it. CaCO3 in solid, it will be CaO in solid plus CO2 in gas. Option C is CO plus 3 hydrogen. Gas, and here also gas. It will be CH4 plus H2O. H2O here will be gas, will be also gas. 2 of ammonia is gas, will be nitrogen plus 3 of hydrogen. This is a neat question. Okay, so how we will solve this? I told you that our question asks which is delta H less than delta U. For our
Ma'am?
delta H less than delta U, our, yes, for this, what we need to calculate delta Ng less than 0, right? To get this answer. Now,
Ma'am,
yeah, say,
what is meant by G there?
G here,
It's gas now, ma'am.
gas. Now,
Ma'am, then how? Why did you write the C option? H2 as G. H2 will be water, na, ma'am, and it will be liquid.
it can be vapor also.
Okay, ma'am.
Okay, water vapor also. Now, see, for this delta, what I told you, how to calculate delta Ng, product minus reactant. I am not writing the whole thing. It is product, number of moles of product minus number of moles of reactant. Remember, this is valid only for gases, neither solid nor liquid. Okay, this is valid only for gases, neither solid nor liquid. See, here all of the things are gases. So what is the delta Ng value here? Here 1 plus 1. So 2 minus 1 is equals to 1. Here delta Ng is greater than 0. So our delta H should be greater than delta U. So this is not our option. Okay, next. This is solid. Now, how to calculate delta Ng for solid? This is also solid. This is 1. So, it will be 1 minus of 0 is equivalent to 1. So, here also delta Ng greater than 0 means delta H greater than delta U. So, this will also not be correct. This part you understood that for solids, we will not consider this one here. We will not consider this one here, okay? Because this is valid only for gases. Is this part clear?
Yes, sir.
Everyone, is this part clear? Now, how to calculate for this? Delta Ng. You say here 1, here 1, here 3, and here 1. So it's 2 minus 4 is equals to minus 2. So delta Ng is less than 0. It means delta H is less than delta U. So this will be our correct option. Let's check for this also. Here delta Ng is equal to 1 and 3. So 4 minus 2 is equal to 2. Here also delta Ng greater than 0. That is delta H greater than delta U. So also this will not be the answer. Check what they have asked you. If they have asked you that in which of the cases delta H greater than delta U, you will be doing the reverse. Okay. So is this part clear for everyone?
Yes, ma'am.
Yes, ma'am.
Yeah, say. We will be doing a lot of sums so that in exam, you thank me. Now, find delta U at 27 degrees Celsius for FeCO3. How to solve this question? It is solid. Okay, this is solid. Solid, FeO. This will be also solid, and carbon dioxide will be gas. Delta H is given as 82 kilojoules. Okay, so what formula we know? What is the formula that we know, that we have learned so far? Delta H is equal to delta U plus delta NGRT. This is our formula, right? Delta H is given as 87. What is delta U? Okay, delta U need to calculate. What is Ng? What is Ng? Here gas, solid, solid. So our delta Ng will be 1 minus 0 or 1. Right? Right or wrong? Arey, say delta Ng is 1
Ma'am?
minus 0. Right? Because this is also solid, this is also solid. We will not be considering these coefficients. Right? Just now I have taught you. So this Ng is 1. So 1, what I asked you to consider are 25/3. What is the temperature? 27 degrees Celsius is 300 Kelvin. I told you if you are using this units, then you will be getting this in joule. But this is in kilojoule. So I will be dividing it by 1000. Is this part clear?
Yes, ma'am.
Whole sum is clear, then you can calculate for you. You will be getting the answer in kilojoules. Okay, so is this part clear? This sum is clear to everyone?
Ma'am,
Yes,
is H 87 or 82?
87.
Okay, ma'am.
Okay. Is this part clear to everyone? Can we move to the next sum? Okay. Question number 3. Last sum is clear, right, to everyone? This one is clear to everyone, right? Ade, respond.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. 1 mole of non-ideal gas. This is also a neat question. Non-ideal gas undergoes a state from 1 atm, 3 liter, 200 kelvins to 4 atm, 5 liter, 250 kelvin with a delta U of 40 liter atom. Find delta H. Okay. See, here P and V both are variables, right? Here P and V both are variables. P and this is V. P and this is V. See, both are changing. So here P and V is both variable. What formula we will use? Delta H is equal to delta U plus delta of PV, right? What is delta U? Okay. What is delta of PV? Delta of PV means P2V2 minus of P1V1, right? What is delta U given? 40. 40 plus, what is P2V2? 4 atm into 5 liter.
Into 5,
Yeah, what is P1V1? 1 atm
1 ATM
into
into
3 liter.
3 liters.
Yeah, so it will be 40 plus 20 minus 3. So it will be 57, right? Liter atom. So is this sum clear? It is easy. Clear? Clear?
Yes, ma'am.
Yes,
Good.
ma'am.
Good, good, good. Why I am making you do the sums after teaching up topic? Because when you will be getting the real life sums, then you will understand that, okay, we have to use this formula here. Okay. So just practice, you will be a pro. You will be a pro in chemistry. Find delta U for combustion of 1.5 moles of benzene. This is also a neat question. At 27°C. The equation is given as C6H6 plus 15/2 oxygen, 6 CO2 and 3 of water. This is liquid, this is gas, and this is liquid. Okay. And delta H,
Ma'am,
yeah, say.
don't we get less sign between CO2 and 3H2O?
Yes. Good, good. Minus 3270 kilojoules. Okay, this is given. Now, let's find out for 1 mole. Here, 1 mole of benzene here. See, anything combining with oxygen means combustion. Okay. So, here for 1 mole, it is given. We have to calculate for 1.5 mole. So, let's calculate for 1 mole. Then we can calculate for 1.5 mole. What is our equation? One of the basic thing, whenever you are seeing an equation given liquid gas, then remember to use this kind of formula. Okay. So delta H is equals to delta U plus delta Ng RT. What is delta Ng? Let's calculate it. 3 and 6. Sorry, this we will not consider, right? Because it is liquid. So 6 and this also we will not consider. Okay, I am crossing it. So it is 15/2. It is 6 minus 15/2. So how much it is? Minus 3/2, right? Right?
Minus 3/2, ma'am.
Yeah, minus 3/2. See, now we will solve. It is given as minus 3270. Delta U we need to find out, plus what is Ng? Minus 3/2. What is R? 25/3. What is T? T is 27°C, means 300 Kelvin. This is 300 Kelvin. Okay, so I told you this is, we are getting in joules. Now we have to divide it by kilojoules. So by 1000. See, in your question, if in place of kilojoule, it was written joule, then you don't have to divide this by 1000. Okay, since it is written in kilojoule, we are doing it, dividing it by 1000, because this NGRT, this we get in joules. Okay. Now, you can just solve it. What it is coming? Delta U is equal to minus 3 to 66.25 kilojoule. Now, this is for 1 mole. So, therefore, for 1.5 moles, what will be the answer? Minus 3266.25 into 1.5 something kilojoule. Whatever you will get, that is the answer. So, is this sum clear to everyone?
Yes,
Is
ma'am.
this sum clear?
Ma'am, I don't get why did you divide it by 1000, ma'am?
Okay, you are not listening. See what I told. Here. See, where is it? I told you what? We will be taking H in kilojoule, U in the kilojoule. Now for NGART, this part, we will be taking N in moles and R we are taking in joules, okay? And T is taken in Kelvin, okay? So if you multiply this moles, okay, wait. So what I have told you for NGRT, Ng is taken in mole. What is R taken in? Joule per mole Kelvin. And what is T? Kelvin. Kelvin, Kelvin, mole, mole. So you are getting this NGRT in joules, but we have taken this two in kilojoules. So to convert joule to kilojoule, we will always divide it by 1000. Okay. Whoever asked me the question, is this part clear?
Yes, ma'am.
Okay. So for every question, see, for here also I have, this is given in kilojoules. So I have, this is in joule. This is in joule. So we have done it by, divided it by 1000. So ultimately it has become kilojoules. And this is also kilojoule. So kilojoule to kilojoule. If in your question, instead of kilojoule, 87 joule is given, then your equation would be delta U plus 1 into 25 by 3 into 300. Okay, no need to divide it by 1000. If in place of 87, it was given as 87 joules. Okay, then do this. Then don't divide it by 1000. Clear? Clear or not?
Yes, ma'am.
So that is the reason I was dividing. Now let's start with heat capacity. I will write the definition only once. Rest of the definitions you will be understanding. Heat capacity. Now, how to read heat capacity? First is C or CT. When you are writing when you are making your own notes, write that this is the total heat capacity. What is this? This is the total heat capacity. It is the energy or heat required to increase temperature of a system by 1 degree Celsius. Okay. Okay. So what is it? Unit, how it is represented? C is represented as plus Q by delta T. This is a path function. And this is an extensive property. I have already told you just to make you reminded. Okay, so amount of heat required to increase temperature of a system by 1 degree Celsius. Next is CM. CM is molar heat capacity. Okay, this is same energy or heat required to increase temperature of 1 mole of a system by 1 degree Celsius remains same. Rest of the thing is same. We represent it as Cm. So this is total heat capacity. This is molar heat capacity. Cm will be plus Q N delta T. Okay. Now one more thing. This is an extensive property, but this is an intensive property. Why? Because Q is an extensive property and this whole thing is an extensive property. And while teaching you, I already told you that when two external properties are being divided, their product is the intensive property. Okay, up to this it is clear to everyone? Clear or not? Up to this? Everyone say, is this part clear?
Yes, ma'am.
Good. Next comes our CS or S. This is the specific heat capacity. So the heat, the amount of the energy or heat required to increase the temperature of 1 gram of a system by 1 degree Celsius. Okay, by 1 degree Celsius. This is specific heat capacity. So CS is equal to plus Q by W del T. W is the work done. We will be learning how to solve these sums in next class. Up to today, you just learn what are those, what are the terms, and what is it. CP. So CP is heat capacity at a constant pressure. Okay. So CP is written as CP is equal to plus QP divided by delta T. Okay. And CPM. What is CPM? This is molar heat capacity at a constant pressure. This is heat capacity at constant pressure. This is molar heat capacity at a constant pressure. We represent CPM as plus QP divided by N delta T. Okay. Now next. Next is CPS. What is CPS? It is specific heat capacity at a constant pressure. Okay, so this is CPS. These are plus QP divided by W del T. Now, next, 7. What is 7? CV. CV is heat capacity at a constant volume. So CV is represented as plus QV divided by delta T. 8 is CVM. CVM is molar heat capacity at a constant volume. So CVM is equals to plus QV divided by N delta T. And this 9. It is CVS. What is CVS? It is specific heat capacity at a constant volume. Okay. So CVS is written as plus QV divided by W del T. I know these are a lot of formulas. Initially, you will be getting confused. What is this? What is that? But with time, you will understand. I'm writing the terminologies also. What is this? It is the total heat capacity. Okay. What is CM? CM is molar heat capacity. Okay. Now, what is CS or S? It is the specific heat capacity. What is CP? Heat capacity at constant pressure. What is CPM? Molar heat capacity at constant pressure. What is CPS? Specific heat capacity at constant pressure. CV is heat capacity at constant volume. What is CVM? CVM is molar heat capacity at constant volume. And what is CVS? It is specific heat capacity at constant volume. Okay, so is this whole part clear? You have to remember these formulas for our next class. So just take a screenshot, or if you are noting it down, just do it. Then I will proceed to the next part. Clear? Up to this clear? So total heat capacity is required to increase temperature of a system. Same thing, temperature of 1 mole of a system. Same thing, temperature of 1 gram of a system by 1 degree Celsius. And these are all the formulas. So up to this, it is clear. I know it will be a little bit tough to remember all the formulas initially, but gradually you will remember. After today's class and tomorrow's morning class, I won't be taking classes because the pressure will be on your brain too much. I know that. So just revise, and then on Tuesday I will be taking after tomorrow's class I will be taking class again on Thursday next week. Okay. So up till then, just try to revise. Okay, can I move to the next part? Mayer's equation, Mayer's relation.
Yes, ma'am.
I know this part will be whatever I will be teaching today and whatever I will be teaching you tomorrow, it will be heck of a load. Now let's start. Let's start. What is our equation? Delta H is equal to delta U plus NR delta T. Listen to this carefully. Now we will be dividing both sides by N delta T. Delta H divided by N delta T is equal to delta U by N delta T plus NR delta T by N delta T. Okay, up to this clear? Now, delta H, what I told you in today's class, what is delta H? I told you to remember those things because we will be needing this. Where is that? Where is that? See here. Delta H is QP, delta U is QV, right? So I will be just writing that. What I will write? Oh. This is delta H is QP. So divided by N delta T is equal to delta U is QV divided by N delta T. And this cancels out. So R. QP by N delta T is CPM. Okay. If you see here, this is CPM. Where is CPM? QP by N delta T. And QV by N delta T is CVM. Okay. I'm just replacing it. It is CVM plus R. So what equation we got? CPM minus CVM is equal to R. This is a very important formula you have to remember. This is the Mayer's relation. This is the whole derivation, and this is what you have to remember. Clear, everyone? Clear, everyone?
Yes, ma'am.
Okay. Now I am deriving another formula. Another formula. This is not Mayer's formula, but from Mayer's formula we can derive this. What we got? CPM minus of CVM is equal to R. Already we got this. Okay. Now what is CPM? CPM is QP divided by N delta T, right? See. QP by N delta T, and what is CPM? QV by N delta T. It is QV divided by N delta T. It is R. Okay, now see the magic. What is QP? See, this part and this part. This part you can write it as CP, and this part you can write it as CV. What is CP? Only CP, not CPM. What is CP? QP by delta T. And what is CV? QV by delta T. Okay, I have just written that. So it is CP by N minus CV by N is equal to R. So what is the equation we are getting again? So it is CP minus CV. I am taking 1 by N as common is equal to R. So CP minus CV is equal to NR. Okay. This is another equation you have to remember. Another formula you have to remember. Clear? Clear? Is this part clear? How I got this? Yes or no?
Yes, ma'am.
Yeah. So in your Neet, a question came as write CP minus CV for 2 moles of an ideal gas. How do we do it? How we will solve it? Cp minus Cv is equal to Nr. What is N given here? 2. 2R. So this is our answer. Okay, is this part clear? Clear? Yes or no?
Yes,
How
ma'am.
will we solve? Okay. And how will I understand that you have understood or not? Next equation is prove that this is also an important equation. Ct is equal to NCm is equal to WCS. And another equation is Cm. These are the formulas you have to remember. Is equal to molecular weight into CS. Okay, these are the formulas you have to remember. I am deriving it. What is CT? CT is the first one, total heat capacity. Where is that? CT. See? Q
Q
by
by
delta
delta
T.
T.
Yeah, so it can be CT or C, whatever you write. After tomorrow's class, start revising. So CT is plus Q by delta T. Okay. What is CM? I am not going back, but
Q
CM
by
is
N.
Q by N delta
N
T.
and delta T.
Yeah, good. What is CS? CS is Q by
Q by
W
W
delta.
delta T.
Yes. Now, okay. This Q by delta T. What is Q by delta T?
CT, ma'am.
And here, okay, wait. Q by delta T. Here, what is Q by delta T for this? Q by delta T. What can we write here? W into CS. Here also from plus Q by delta T. What can we write here? N into CM. So, these three things are equal, right? So, therefore, we can write CT is equal to NCM is equal to WCS. Is this part clear? This derivation? This is an important formula also.
Ma'am.
Okay, this is an important formula also. This is how you juggle and play with sums. Now for this. Okay, now we already got NCM is equal to W into CS. Okay, this is W. This W is what done. Okay, this W and okay. Now, what is CM? CM is W by N into CS. What is W by N? Okay. I don't know which teacher taught you the first chapter, but moles is the given weight. Given weight means whatever the weight that is given in your question by molecular weight. Okay. What it is given here? Weight is given, weight is given. Okay. And moles are given. So molecular weight is equal to given weight by number of moles. N is what? N is the number of moles and W is the given weight. So this is the molecular weight into CS. So hence proof. So CM is equal to molecular weight into CS. This is another important formula. Is this part clear? These two derivations? Are these two derivations clear?
Yes, ma'am.
Wait. Okay, now for if they ask you in your question, if they ask you, see, isothermal, for isothermal process, what is C? For isobaric process, what is C? And for adiabatic process, what is C? How you will solve? C. C means the first one. C is Q by delta T, right? Isothermal means delta T is 0. So C will be infinite for isothermal process. Isobaric is what? C is equal to Cp. Remember this at constant pressure. Because in isobaric pressure is constant, so at constant pressure, C becomes equal to Cp. Adiabatic means what? C means what? Plus Q by delta T. Adiabatic means Q is equal to 0. So obviously C will be 0. Is this part clear? This 3. Is this part clear?
Yes, ma'am.
Good, good. Just revise whatever I am teaching na. Just revise. You will be a very much pro in thermodynamics. For isochoric, what will be the C? C will be Cv. Because for isochoric, volume is constant. So C is Cp, C is Cv. This is for isochoric process. Okay, clear?
Yes, ma'am.
Okay. Okay. I will be torturing you today for a lot, because before me going to a holiday, I need you to understand this. And I don't know where Himanshu sir has made an accident, whether he will be able to take the class. So from tomorrow, after tomorrow's class, tomorrow is Friday, right? Saturday, Sunday, Monday, I will not take class. I'm not sure about Tuesdays, but these 3 days I will not be taking the class. Now for gaseous mixture. Till now, we were calculating this CT, CV, and whatever, CVM, CPM for one gas. Okay, we were calculating this CPM, CVM for only one gas. If they have asked to calculate you for a mixture, like CVM for a mixture, how you will calculate? The formula is, wait, let me write. Let me write, then I will explain. Suppose there is a mixture and this mixture has 3 gases, okay? Then we will calculate CVM for first gas, CVM for second gas, CVM for third gas, multiplied with the number of moles. Then we will just add the number of moles. Similarly, to calculate CPM, we will calculate CPM of the first gas, CPM2 of the second gas, CPM3 of the third gas. And then we will just do the summation of all the 3 number of moles. And this is the Poisson's ratio. Poisson's ratio, okay? This Poisson's ratio is just divide this by this, okay? So this is for first gas, second gas, third gas. Is this part clear? Again, this is for first gas, second gas, third gas, Don't make a mistake that you have forgotten to calculate, multiply it with N1, N2 and N3. This you have to multiply. Don't make this kind of careless mistakes. Up to this clear?
Yes,
Yes.
ma'am.
Everyone? Wait. Just wait for once. I'm coming. Just wait for one. So, sorry for the interruption. Let's start with sums. Okay. What first sum? This is a JE question. 5 moles of oxygen is not added, heated. At constant volume from 10 degrees Celsius to 20 degrees Celsius. Find delta U. It is given Cp is equal to 7. This is a very good sum, very good sum. Mole Kelvin and R is 2 calorie per mole Kelvin. Okay. Now, let's do one derivation first. I didn't teach you that derivation. I forgot to teach you the derivation. Here, let's do the derivation first. What is CVM plus QV divided by N delta T? Right, this is our CVM. Okay, what I told that QV can be written as delta U. Delta U divided by N of delta. So from this, what can we write? Delta U is equal to CVM N CVM delta T. This is another important formula you have to remember. Okay. Since I'm teaching you here, let's teach this here also. Like this also, what is CPM? CPM is plus QP by N
N
delta.
delta T.
What is QP? Delta H. Delta H by N delta T. So, delta H can be written as N CPM. Wait. Delta T. So, this is also a very important formula. You have to. Okay. So, up to this, it is clear, right? Hopefully. Now, see, in our question, what it is given? Cp is equal to 7 calorie per mole Kelvin. What it is being written here? Calorie per mole Kelvin. Right. Here see, calorie per mole is given. So this Cp becomes your CPM. So your CPM is equal to 7. Did I make you clear why I am considering here CPM is equal to 7?
Yes, ma'am.
Okay, now what is the formula? CPM minus CVM is equal to R. Right, this is our formula. What is CPM? CPM minus CVM is equal to 2. So what is CVM? 5. Up to this clear?
5.
Up to this clear? Now, we will be using this formula. They asked us to calculate delta U. Delta U is N CVM delta T. What is N? 5. What is CVM? 5. What is delta T? 20 minus 10.
10.
Yeah. So what it is, whatever you will get, that will be in calorie, is 250. So is this whole sum clear?
Yes,
What
ma'am.
I have done? Easy? Easy, right? Is this part easy or difficult?
Easy, ma'am, I think.
Okay. Now you have to see, in thermodynamics, I am just marking you these formulas. In your exam, you have to just identify which formula to use where. Bas, you are done. You will solve the question. Okay, let's do not another sum. Okay, next class, we will be starting with the adiabatic process. But here, just learn for something, adiabatic process. What is adiabatic process? See, in your question, they can also write it like isolated system or insulated container. These all things, if you see in your question, you will realize that it is an adiabatic process. Okay. In adiabatic process, Q is equal to 0. What is our first law of thermodynamics? Delta U is equals to Q plus W. According to first law of the thermodynamics, this is 0. So delta U is equals to W. But we in adiabatic process, we don't write here only W. We write it as W adiabatic. Okay. Is this part clear?
Yes, ma'am.
Okay. See, delta U is again what? What is delta U? Just now I told you.
Q
N,
plus W.
no, not that. NCVM delta T. Okay. So therefore, W adiabatic is equal to NCVM delta T. Now, details of this, how to use this formula. Now, there is a difference between reversible and irreversible process to calculate this delta T, okay? That I will be teaching you in tomorrow's class, not today's class. But for today, just remember up to this, okay? Is this part clear? Up to this, is this part clear? Then I can move to the next slide.
Yes, ma'am.
Yes, ma'am.
Okay, so just write it as star mark. Isothermal versus adiabatic process. I will not be explaining you this part also. Adiabatic process. Just trust me today. This we will all learn in tomorrow's class. Maybe, hopefully, we will complete. If I can't complete whatever I have decided to complete by this week, by tomorrow's class in morning, then I will take an extra class on Sunday. If I can't complete it by tomorrow morning. See, this is a PV graph. This is an isothermal process. This is an adiabatic process. Now you will ask me, ma'am, in this graph, why isothermal is above adiabatic? This answer, to get this answer, you have to see tomorrow's lecture whole. including the extra class I am telling you. But for now, just trust me that if this is the case, then isothermal will be above, adiabatic will be below. Okay. Now to explain these also, we need to learn about gamma. Okay, gamma or the Poisson's ratio. And to explain this gamma, we have to start with degree of freedom. Up to this, it is clear why we are learning degrees of freedom. So let's roll. This is something you will enjoy. Degree of freedom. Okay. Okay. For degree of freedom means mode of movement. Mode of movement of a gas. Like how a gas can move. Like if I leave you in a room, how you will run? Are you going to jump or are you going to run? So mode of the movement of gas. No, sin, please remove this. No, sin, remove this and you added another one. I can't remove. So no, sin, please remove this. Okay. So there can be three modes of the movement. One is the translatory. Second is the rotational. Third is the vibratory. This is T, this is R, this is V. Translatory means how a molecule is moving along an axis. X-axis, Y-axis, Z-axis. Rotational means how the molecules are moving along a bond. And vibratory is not in your syllabus. This very rarely comes in JEE Advanced. Okay, so we will not be learning about this vibratory. So vibratory is a long concept. You can, if you take chemistry as your honors, you can learn about this. But since this is not a part of your syllabus, we will not focus on this vibratory a lot. This question rarely comes in your JEE Advanced. Okay, so now can we start? Okay, so just give the heading gas, then F, then CVM, CPM, and there comes gamma. So what are the types of the gases? This is monoatomic. What is a monoatomic gas? Monoatomic gases are inert gases like helium, neon, etc. Okay. So F means degrees of freedom. What is F? F is the degree of freedom. Okay. So for monoatomic gas, imagine this. This is a monoatomic gas. Okay, this is a monoatomic gas. Now, these are the three axes. This is the Z, this is the X, this is the Y. So if I leave this gas here, how will it move? It will move like this. Okay, this is the extrapolation of negative X-axis. This is the negative Z-axis, this is the negative Y-axis. If I leave the gas here, monoatomic gas, okay, how will it move? It will move like this. Okay, it will move like this. It can move also like this. Is this part clear? If the gas is monoatomic, it can move like this, it can move like this, or it can move like this. So there can be three translatory motion. Up to this, is it clear? Yes or no? I have to do a lot of things. Just say yes or no. Okay, then I am removing this. Okay, so this is the 3T. What is the, does monoatomic gas has any kind of bond? This is just a helium. So there is no bond. And if there is no bond, there will be no rotational movement. So this will be 0R. So total, this will be 3. Okay. So for CVM, the formula is, F by R. No, F by 2. Yeah. And for CPM, the formula is CVM plus R. And for gamma, the formula is CPM by CVM. Yeah, the formula is CPM by CVM. Okay, so if this is 3, then what will be this? This is 3R. Yeah, this is 3. This is 3R by 2. The formula is R, FR by 2. 3R by 2, and what is this? 3R by 2 plus R. What is this? 5R by 2. And here 5R by 2 divided by 3R by 2, it is 5 by 3. Okay. No, sin, please remove this, or else I am not able to write. Next comes our diatomic gas. So for diatomic gas, it is hydrogen, HF, HCl, chlorine, nitrogen, oxygen, etc. What happens for here? See, even if the gas is like this is a diatomic gas. And this is something. So this gas can also move like this, or can move like this, or can move like this, right? So there will be 3 translational. And since these 2 gases are bonded, they can move like this. Like they can be moving like this, or they can go, this bond can go like up and down, up and down. Okay. Either they can move like this, or they can move like this. Okay. So there are 2 rotational. So total there are 5 movements. So what are this? This will be 5R by 2. This will be 5R by 2 plus R. 5R by 2 plus R. So what will be this? 7R by 2. And what will be here? 7R by 2 divided by 5R by 2. That will be 7 by 5. Is this part clear? Everyone, is this part clear? Is this part clear? Yes or no? Are no one is replying. Is this part clear?
Yes, ma'am.
Good. So just try to say triatomic. What is triatomic? Triatomic gases can be of two types. Linear, like carbon dioxide, what I can think of. And another triatomic gas can be non-linear, like SO2. Okay. So now just think for triatomic. Triatomic gas linear means like this. So this gas can move like this, can move like this, can move like this. Okay. And for him, 2 bonds are present. They can move like up and down, or they can move horizontally. Okay. So what will be the what will be their translational and rotational? So this will be 3T and 2R. So total will be 5. But for them, 3D is fixed. They can move like this, they can move like this, they can move like this. But this bond can rotate, this bond can rotate, and overall this structure can rotate. Okay, so there will be 3 rotational bonds. So total it will be 6. Okay, so this is what is happening. So now, so what will be this 5r/2? Again 5r/2 plus r, that will be 7r/2. So this will be 7/5. And this 6r/2. So this will be 3r. 3r plus r. 3r plus r will be 4r. And that will be 4/3. Okay. So what is the value for? So is this whole chart clear to everyone? Is this whole chart clear to everyone?
Yes, ma'am.
Okay. So gamma will be maximum. I am writing from maximum to minimum. Monoatomic gas, then diatomic gas, then triatomic gas, linear, and then triatomic gas, non-linear. Okay. So this is the value for gamma. Maximum for mono, then di, tri, and okay. So now, up to this, everything is clear to everyone because this has a value of 5/3. This has a value of 7/5. 7/5 for these are actually same, but experimentally this has been found. And then this has been found to be as 4/3. So now, up to this, is this part clear?
Yes, ma'am.
I will just say a brief about vibration. Something, this is only students targeting for JEE Advanced, only for JEE Advanced. Now, see one thing. If they ask you the total degrees of freedom, total degrees of freedom means translational plus rotational plus vibrational. This will be 3n. Okay, what is n? N means number of atom in a gas. Okay. Up to this clear? So N will be 1 for monoatomic gas. N will be 2 for diatomic gas. And N will be 3 for triatomic gas. Right or wrong? Triatomic, linear or non-linear? Both. Up to this clear? Everyone? Up to this, is this part clear to everyone?
Yes, ma'am. Yes, ma'am.
Okay. So total DOF, total DOF for monoatomic gas will be 3 into 1. Total DOF for diatomic gas is 3 into 2, 6. Total for triatomic gas is 3 into 3, 9. Right?
Yes, ma'am.
Okay. So, if you see the chart, I'm writing this chart here only. Gas, and the value of F or the degrees of freedom. For monoatomic gas, it was 3. For diatomic gas, it was 5. For triatomic linear, it was 5 again. And for triatomic non-linear, it was 6. Okay, so this was the basic thing we have already learned. See, from this calculation, what we got for monoatomic gas, it is 3. So it is 3 here also. So for monoatomic gas, how many vibrational energy will be there? 0. Okay. For diatomic gas, by this formula, considering all the 3, we are getting here 6. But without considering V, we got here 5. So how many vibrational? 6 minus 5, 1. Similarly, for triatomic, by considering everything, we got it as 9. Okay. But considering only these 2, we got it as 5. So 9 minus 5 is 4.
4.
Here 9. 9 is fixed. But here we are getting 6. So it is
3.
So this chart is required only for JEE Advanced. Okay. Clear, everyone?
Yes, ma'am.
Today's class. Now, so I want to ask you one question. Up to today, whatever I have taught you in thermodynamics, is this part clear? I know you have forgotten a lot of formulas and derivations. That's okay. But did you understand the concepts?
Yes, ma'am.
Every sum, where to use what values and so on. Everything you understood, right?
Yes, ma'am.
Okay. So tomorrow morning, I will be starting with the very long relation between PVT. Tomorrow we will be doing only the adiabatic process for reversible adiabatic process. This is a huge one. I will be doing it with you tomorrow. Okay. Done. Okay. So I'm stopping sharing. Okay, I took a long class. I think it is more than enough. Yes or no?
Yes, ma'am.
Yeah. So tomorrow also I will be doing more than enough stuffs. Tomorrow actually more than enough than today's class also. And if I can't finish tomorrow, then I will be taking one extra class on Sunday. Okay? Okay. Okay then. So, ma'am, this was from my part.
Yes, ma'am. Thank you, ma'am. Yes, students, again we will meet tomorrow morning from 5 to 7. We have class tomorrow morning from 5 to 7. Bye, everyone.